gambling?
It's not gambling.
All right. So.
Oh, that's cool.
Yeah. So actually, my other screen's booting up, so we don't even need this top screen on. So today, we're discussing probability. Probability of things happening. Probability of things not happening. A probability of you being able to predict an outcome. So I thought that I would kind of hook you into this activity with an example of why probability is so important. So on my desk, you see that I have a few different objects that probability is often involved with. This die is a little bit complicated to see, but one cool thing that you can see with this die, if you've never noticed, the opposite sides of a die will always add up to 7. So see that the 1 is opposite the 6, the 3 is opposite the 4, and whatever one I didn't show, the 2 is opposite the 5. They will always add up to 7, the opposite sides of a die, if it's a fair die, that is. So switch this to continuous focus and see if that helps. Huh? Because if certain sides are right next to each other, then you're more or less likely for certain sums, or it gets really, really complicated. But each side would still individually have the same probability. It's just when you start doing things together. Yeah. So I've shuffled up your class group of cards. So what is the individual probability that you will be drawn at this moment?
1 out of 5.
How many people are in this class? Good question.
Now there are 17 people in this class. There were 18 when Leah was still here with us. Okay, Shahid?
1 for me being chosen out of everybody else in this class is 1 out of 17 people.
1 out of 17 people, right? So what happens if I draw Zach as our first person?
Yep.
What is your chance now, Shahib, of being drawn now?
Yeah. It's still 1 out of 17.
Are there still 17 cards to be drawn?
No.
No. 1 out of 16. So this gets into. Nate, can you scoot back a little bit because you're kind of blocking some people's view. Back into the row. This gets into when you do or do not replace things. So last week when we did the little probability lab, to intro you guys into this, when you were drawing cards from the deck, did you guys replace them as you went?
No.
If you don't replace them as you go, you're constantly changing the probability. If you do replace them as you go, then your probability stays the same. So if after I draw Zach, I put his card back into the deck, your individual probability stays the same, but now I could draw Zach again, which wouldn't really be fair to everyone. So Zach, you're first up.
Oh, cool. Okay.
What, and actually I guess I won't show all these, because they have your first and last name, I'll not show the other ones on the screen. I have my chip. Red versus yellow. 2 outcomes, right?
Yes.
I will wager 1 Dum Dum, or Starburst, or Hershey Kiss, or whatever I have up here, that you cannot guess this outcome correctly. What outcome do you think is going to happen? Red or tan, or yellow, or whatever color you want to call that.
Which one's not going to happen?
Which one will happen? You're trying to predict what will happen. You're trying to be right.
It's like flipping a coin.
It's going to be tan.
Tan?
That was gnarly.
Okay, that flipped way faster than a quarter does. I gotta tune back.
That was good, no. It's red.
Oh!
Zach wins. Noah, I will place the same wager with you. 1 of any of the objects up here, what color do you think will happen? Red.
It's yellow.
Sorry, Noah. Shahib, I'll place the same wager with you.
Wow, he had a 3 and 50 or 1 and 50.
Wait, so we get a piece of candy for
If you're right. Yep. If you are right, you get a piece of candy.
Red.
Red? Ah!
You're doing great.
This thing is crazy.
You should just get a quarter next time.
I'm on a strict no food other than candy diet.
All right, we'll do one more so that we have 4 trials. Karen, red or yellow?
I want the bad.
Yellow?
Yellow.
So wait. So what is our current experimental probability? I don't know if Smart Ink works on top of this or not. What is it?
3 out of the 1.
3 out of wait,
4.
3 out of 1. 3
3
out of 4, right? So our current experimental probability is 3 out of 4. Is that matching our theoretical probability? No, so right now you guys have been luckier or more successful than what the theoretical probability tells me. Unfortunately, Noah was the only person who was not successful. So now we move on to colors. Now I will wager 3. 3 of any of my objects up here. So now, what is your probability of having your card drawn from the deck? Jackson?
How many cards are there in total?
Well, there are 17 students in here, and we just did 4 trials.
1 out of 13.
So now your probability is 1 out of 13. You are having a better and better and better chance of being drawn.
Don't draw me.
Jackson, ironically. What color would you like?
Purple.
Purple.
Oh, that's what I was gonna say.
Yeah, I feel it's more
I like how you guys can't see it once it starts to spin.
Oh,
Green.
Yeah.
Sorry, bud. Seth, again for 3.
Because there's 5 colors, not 2.
I know.
I'm gonna go blue.
Go blue.
Oh, Seth got it. 3 of any of the up here.
Oh my goodness.
Yeah, we moved on. Lily.
You know,
They have to be the same thing.
No.
Red.
Red. Ah, blue again.
gross. That smells like eggs.
Ella.
Oh, okay. I'm gonna say
I smell good. Not really.
green.
Green.
You always smell
I know.
Red. There's your red, Lily. And Pranav. So we have 5 of these. Pranav, what color is your prediction?
I like red the best, so red.
You like red the best?
Yeah.
Red's my favorite color.
Purple has the most.
Ah, blue again.
Dang it.
So what was our experimental probability there? How many people got it right versus how many people did it?
Uno.
1 person got it right out of 5 that we did. Does our experimental match the theoretical?
Yeah.
Yeah. In this case, it did. Would it always?
No.
No. Experimental's not always going to match.
Are we just doing this the whole time?
Not necessarily the whole time.
Yeah,
We
just
should.
go through until everybody does.
My die, but I'll use one that's easier to see.
Good.
My die.
Use the big one.
Now, I'm going to wager 4.
We should do 5.
Peyton.
No. Okay. 4.
4? 2. Sorry.
Do 6 trials this time.
I want the card.
Olivia.
3.
Ooh, Olivia got it.
Yo,
4 of whatever you want. And you guys are allowed to share your winnings. That is encouraged. Ashton. 5. Oh!
my goodness.
Ashton got it.
Oh my god.
Carrie.
2.
2. Oh, it's a 6.
No, that's a 2.
Grace.
still haven't picked
3.
3. Oh. There's your 3, Grace. It went off the screen, but yeah. So wait, so we started with Peyton on the die, right?
Yeah.
Yeah.
So 1 more for the die. Nate.
No! Oh no, 6.
6.
It's not one.
It's a 3.
Oh my gosh!
What?
I was gonna pick 3.
What is the experimental probability of what we just did? How many people got it right? 3, right? How many people did we do?
6.
6. So our experimental probability simplified
Throw me one.
is 1/2 or 50%. Does that match what we would anticipate?
No.
No, so you guys are on it today. You guys so far in every trial that we've done have had better experimental probability. Well, except for what one did we match on?
Mine.
Yeah, we've either matched or been better. So right now, apparently this room is lucky, is what that's telling me.
Good juju. Good juju.
Actually, we'll do this. If you don't know how a deck of cards works, there are. Sorry, that's kind of a trippy viewpoint. So there are 52 cards. They're broken up into 2 colors, red, black. They're broken up into 4 suits, hearts, diamonds, spades, and clubs. And they're broken into 13 card denominations: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. So if I ask you to predict the...
Is it exact card?
Everything.
Yeah, this is a perfect fair card deck.
Do you get a point for everything you get? Like if you get the suit right, if you get the
How
get
many
the
do you
color
get
right,
if you get the colors?
and if you get the number
So
right.
hold up. Let's go back to suit.
Witchcraft.
Suit is not too hard because I just want to finish out the deck so I can shuffle you guys back up. So for suit, for guessing the suit, Rye, I will only wager 3 because you're guessing the suit. What suit would you like?
I'm feeling loving today. So
Feeling
I'm gonna
loving.
go hearts.
Hearts?
It's on the bottom.
I saw the bottom one. But
Yeah, you
I'm
can't pick
not
the
gonna
bottom
take
part.
it. Oh.
He got a spade. So, in order to keep my probability fair, I need to replace that. And our last, James.
Okay.
What would you like?
Diamonds.
Diamonds. Diamonds are forever.
Yeah.
Ah, you got diamonds. What was his probability?
1 in 4.
1 in 4. What probability if I stop right now? What's our experimental?
How many do I get?
1 in 4.
One and two.
So if I stop right now, our probability is 50%. What could I do to get my experimental? What could I do to get my experimental probability closer to the theoretical? Test it more times. Run more trials. Because the law of large numbers. Have I talked about this in here yet?
Yeah.
So who can remind me what the law of large numbers tells me? Olivia?
The more trials you do, the closer you'll get to the theoretical probability.
Yeah, the more trials I perform, the closer my experimental probability will be to my theoretical. So, we're going to step up the game now. 8-section spinner. Your deck of your class is being completely shuffled. What is your probability of being drawn again? 1 out of 17, not very good, right?
No.
This spinner, I will wager 4 of anything.
I said 5.
We're
Minus
waiting for
1.
5.
5 minus 1.
We're getting to 5, don't worry, we'll get there to wager 5.
What about all?
So, you need to pick a number 1 through 8. Our first contestant, Ella.
Oh!
What number?
7.
7?
Lucky 7.
It got
It's between, it's really a 2.
Oh,
Our next contestant, Olivia.
She always got something.
So,
3.
oh, it's a oh.
It's a 1. Our next contestant, that's the entire class, Grace.
8 minus 4.
Oh,
We got a 3. Ashton.
7. It's a.
Hey! Got 4.
So lucky.
4 of anything. Pranav.
Oh gosh. Oh, 4.
4? Ha!
That's not even.
Yeah,
fair.
that was not a very good
Spin
spin.
that. You still get it.
Yeah, you still get it.
Yay.
We're near the end of the year.
Yay.
That doesn't count.
I get
1,
like-
2, 3, 4, 5. So if we stop right now, what's our experimental probability? 5 people have done this.
2 and 5.
2 out of 5. So what percent would that be?
40%.
40%. Hold up.
I said 40.
Your actual...
I said 40.
Hey gentlemen, do I need to separate you? The actual 1/8 probability is 12.5%. Right now, we're running a 40%. But if we do this more trials, we would expect more wrong outcomes, and that would get us closer to that theoretical. So now I wager 5. Now my wager
Stakes are
is
high.
5. Stakes are getting high. Now my wager of 5 is relative to you picking the correct numerical outcome. Suit does not matter. Color does not matter. You are choosing ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Suit does not matter. So Peyton, what numerical outcome?
Did you put all the cards back together?
Yes.
Let's go
7. So Peyton is looking for a 7.
That's what I was gonna say.
Do you want to do the draw or you want me to?
You do it.
Okay.
Here we go.
All right. What's the probability this card is a 7?
I'm going
One. Hold on. 1 out of what?
52?
It's not 1 out of 52.
4 out of 52.
12. Wait.
It's okay. So it's 4 out of 52 because there's 4 sevens in the deck, and that would reduce down to 1/13.
That's a great chance.
We got
Oh.
James for a wager of 5. What numerical card would you like to look for?
8.
8. So James is stepping up 1 from Peyton. So looking for an 8.
If there's an 8,
How you feeling?
$100.
Ryan's got $100
That's just
on the
immature
line.
and annoying. So if you want to stay in my class, behave better.
$100.
You think this is an 8?
Why should it be an 8?
Oh.
No.
9. Zach, what numerical card would you like to look for? Yellow? That's not. What? Jack. Zach wants a jack. Zach is looking for a jack. Which one, Zach?
That will buy him a Mac.
This one?
Yeah, the wrong one.
Dude, no.
So you're looking for a jack. Got a king.
Wait, see what the other two were. See if they were jacks.
Nope.
That one was better than Jack's.
Carrie. What numerical card would you like to look for? A queen? What do you want? Left, right, center? Center?
Oh.
There's the jack.
This is rigged.
What are the others?
This is rigged.
Oh, what are the others? 10 and 2.
I'm gonna do the math.
We already did the math. There's 1/13 chance.
Well,
I want
I
that
choose
card.
king. Yeah, I pick a king.
Ow.
Let's do one more numerical.
I don't care.
Nate.
Oh. Nate, don't dog.
Jack.
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 Jebediah.
Jebediah.
Left, right, center. What do you want? Left. Got a 2. Check your other options. See if you had any chance. You did not. Not with those 3.
Hey, I get it. Mango.
So now we're gonna up it. Way up.
Here come the stakes.
Where's your
Now, I learned from my mistake with Math 7. Luckily, Lainey was a nice person and traded me back. She had won the entire bag of suckers. None of you would have dum-dums right now. She was not a such a polite young lady. She traded it back for one of the bags of Hershey Kisses. So now I will say, you can have.
25.
I was just thinking 20.
Ooh, 25.
So, because 20 would be enough to share with everybody in here that did not get anything, or whatever group you would want to. So now I will wager 20. I would wager the entire bag of suckers. Let's metaphorically imagine I'm wagering the entire bag of suckers, but I just can't because the outcome did happen last week, and I need to still have some candy to last through the rest of the year. So we'll wager 20. Now I will caveat, you may not eat all 20 of those here. You may eat 2 here and take the rest home, or share the rest. You cannot just get on an epic sugar high. But you must predict a specific card. So you would need to predict the 7 of clubs, or the king of diamonds. So numerical and suit specific.
How'd she get this?
So right now, to predict a card, what is your probability of getting one specific card in the deck? Lily?
1 out of 52.
1 out of 52. So far, I've done this trial 9 times and had 1 winner. So right now, the probability experimental of my experiment is 1/9 versus the theoretical of 1 out of 52.
How do magicians do this?
I mean, I can show you a very simple magic trick here at the end of class. But, so, to make this even more stressful, I'm bringing the deck to you. Lily, which is appropriate since you just told me the theoretical probability. What card are you searching for? What card do you want to get? You cannot say the Jack of Diamonds because it's on the bottom and you probably just saw that.
Okay.
7 of Spades, which I think you also just saw, but I had no idea where it is because I shuffled. That was 7 of Clubs. So, your choice. 52 cards, 1 of what you want is in there. 3 of Diamonds, not the 7 of Spades.
Wait, are you doing this to multiple people?
Yeah.
Really?
Wait, I'm not doing it though.
Rye. What card are you looking for?
Shoot. The 5 of Spades.
5 of Spades. You guys like spades?
It's a very nice card. I like this card right here. I like the way it looks.
Okay. The 7 of Spades now. So if Rye had stuck with Lily's guess, he would have gotten it. Next up, Jackson. What card are you looking for? Now some of you look really nervous and some of you don't look nervous at all.
I wasn't.
Pranav, what's your probability of being picked right now?
Well, how many people? 2 people, 3 people.
What?
What's your probability of being picked in my deck of cards right now?
14.
You've already been picked. The deck that I'm working with, there's only these 4 cards left, and those are only cards that haven't been drawn this round. So what's your probability of getting drawn?
4.
You've already been drawn. Notice the sucker that's in your mouth. You've already gone this round. Your probability is 0. Some of you in here right now have no chance of being drawn right now because the deck would need to be reshuffled and reset. This is what we talk about with replacement. Stop making extraneous noise.
I was singing a song.
I don't care. That is not relative to class. If you want to sing a song, leave my room. So, with and without replacement are very, very important specifications. You will not get very deep into that this year, but next year your probability topics deal with what happens if I don't put things back in the deck. How does that change the probability? Or don't replace things back in the jar. So, Jackson, what card are you looking for? Ace of Spades. The Ace of Spades. There are songs about a lot of cards. Jack of Hearts. It's funny that Jackson got a Jack. All right. Karen, what card are you looking for? The 6 of Diamonds. It'd be nice if we had 6 diamonds. We could maybe do some improvements to the building. 10 of Spades.
We got so many spades today.
So that, I mean, we could track how many spades we got relative to everything else. Shahib, what card are you looking for?
Okay. I have to do something good. 7 of clubs.
7 of clubs. The one to the right, there's nowhere to the right. He got Jack of Hearts. Our last 2 contestants, obviously you know who you are if you haven't been drawn. Noah and Seth will be our final participants.
He can go first.
All right, Noah, what card are you looking for? Ace of Hearts. He must be a lover. I don't care. What is it? Hearts or clubs? Okay, Ace of Hearts.
Wait, do you like the card?
Oh yeah, that's my favorite card. Oh, actually I didn't get it.
4 of clubs. And Seth, what card are you searching for? 5 of clubs.
Yeah, I think it says on the king.
Top
Jack.
Ooh,
Like the
I don't like that card. Yeah, I like it.
Oh. 9 of clubs.
Maybe next time.
So what's our experimental probability for picking a card out of the deck? Well, it's 0 out of how many trials we just did. And although that doesn't match the theoretical probability, that's what we expect a lot of times, because when something is unlikely, it's not going to happen very often. It might never happen through my trials, although theoretically it should happen eventually. It may never happen through my trials. So we're going to cover a little bit of content very fast here. And you guys do have homework, but it's not due for a while. So just get it done as you're able to. Anyone want to pass out notes for me?
Well, I'll do it.
That would be wonderful. I would appreciate that. They're over in the bin.
My bone is out of my leg.
Wait, 93.5?
17.1. I didn't know if we were going to get the probability to see if we sent these copies over to the copy center.
Stop it. Stop it, guys. Wait.
She's come back in the wrong order.
Don't tell anyone.
317. You know, pass those out. We're going to cover
What is
those
the
really fast, I
likelihood
think.
of it being...
So you're going to get 2 sets of notes right now. 17.1 and 17.2. Make sure you have both sets. 17.1 and 2.
I can put that back.
Set. This is your final warning. Stop making noise that is unnecessary. You're like a child. And I know you can behave better. I know you can. You are just making the choice not to. So please make better choices. I can see on the faces of your peers, they get annoyed also. You have both, right, Colonel?
Yeah.
17.1 and 2. You should have both. We're going to skip the first part of that first set of notes. We're going to run through these really fast. So we're starting on 17.1. Your homework has been on the homework board all day. It's 17.1 and 2. I don't know how you had an extra and I didn't. Anyone missing 17.2?
There's an extra 17.
Oh, that would be why. So, when we talk about probability, we use a scale of terms. Now, if you went to your parents and said, hey, can I stay the night at a friend's tonight? And they said, probably. And you, okay, well, you let that simmer for a little while. And you go back to your parents and you say, hey, can we go to Olive Garden for dinner? And they say, probably. You go back to your parents later and say, hey, can I ride my bike down to the store? Probably. Is their response. You ask your parents, hey, can I go work on the computer? They say, probably. And so you start to get frustrated. And you're like, no, what? Probably. What does probably mean? What? Sorry, what?
Likely.
What do you mean likely? Is it yes, it's likely,
Like the
it's
likely-
not likely, it's what?
The light green one right on the screen here. That's his likely.
So what if somebody says, we probably won't?
I think it's unlikely. Yeah, that we're going to this is likely is not.
So what I'm trying to get at, probably is a terrible word. It really does not define anything. When people answer by saying probably, that's really a crappy answer. If they say it probably will happen or we probably won't do that, then it gets better. But we like to use words involving likely. It is unlikely. It's fairly likely. It's as likely as not. So this is a scale going from impossible, which is a probability of 0, to certain, which is a probability of 1. Probability ranges on a scale from 0 to 1, with your as likely as not being your 0.5 or your 1/2, which is really what people often nickname as 50-50. That means you have a 50% chance it will happen, a 50% chance it will not happen. What event that we just saw is a 50-50? Coin flip. We can also make a dice roll 50-50 if we look for evens versus odds. We can make a card deck 50-50 if we look for red versus black. So there's lots of situations we can end up making as likely as not. Unlikely, this is right around that 0.25 or a 1/4 chance. And then if it's very unlikely, it's even less than a 1/4. If it's likely, it's probably at least 3/4 or 75% chance, which as a decimal we all know is 0.75. And if it's very likely, then it's probably up here closer to 1. Questions on this? The terms that we use? So don't use probably, use something involving likely. So let's define or assign those terms, unlikely, likely as not, or you could say 50-50, to these events. What do you think the likelihood of these happening are? So, I guess to go fast, we can just start rolling through. Zach, what do you think? You will go swimming on a hot summer day.
Likely.
Yeah, that's probably likely. It's not certain because you guys would need a ride there. Forget if it's, Likely. There will be children wearing costumes on Halloween. James?
Certain.
Yeah, we know that somewhere I would be able to find a child wearing a costume on Halloween. Guarantee you can. Your hair will grow 5 inches in one day. Peyton, what's the chances of that happening?
Unlikely.
That is unlike. Now, is there any chance of that happening?
No.
That's
5 inches?
impossible.
Yeah, so we would say that this is impossible. You will flip a coin and it will land heads up. Pranav?
50-50.
Yeah. As likely as not, or our 50-50. Make certain you know this is not a minus. It's a dash, right? Hyphen. And a student in your class will become famous next year. Ashton, what do you think the likelihood of that happening is?
Unlikely.
It is unlikely. Could it happen? Yeah, so it's not impossible. It's just unlikely. And we could say very unlikely if we wanted. We could add that, kind of that, it's not really a prefix, but we could add that in front of it to tell us it's probably not going to happen. But it could. So you should already have this from what we wrote above. Probability of an event occurring is from 0 to 1. That is the measure. The closer the value is to 0, the less likely it is to occur. Closer the value is to 1, the more likely it is to occur. And then we have all of our fraction to decimal to percent conversions here on the range of impossible to certain. Any questions? Moving on quickly. So you see here, we could do some work with flags. We're just going to run right through this. We're not going to spend a lot of time. If down here we were looking for probability of a flag with a stripe, we could count how many stripes we have, and we get a 65% probability, or 0.65. That would be 65 over 100, which in this situation, of course, there's not actually 100 flags. But do we have any other questions about how we would determine the likelihood of something happening? It's what you want over total possible outcomes. And we'll do work like this tomorrow. But then moving on to 17.2. Sample space. When we talk about something happening, we have a sample space. Your sample space, I think I need to zoom this down a little bit. Your sample space is all possible outcomes. So I want you to underline, circle, star, something. All possible outcomes is what makes up your sample space. So what is the sample space of rolling a die? 8. 6 is the only outcome?
No, there's 6 outcomes.
But we list each individual outcome. So instead of just saying 6 outcomes, you would say the sample space is or includes 1, 2, 3, 4, 5, 6. You list it out. So make a note here that we don't just say there are 6 possible outcomes. We list every outcome in detail. The action is what you do to get the outcome. Draw a card, roll a die, flip a coin, choose, like it's that action word, it's that verb.
We call it probability.
Why did this go back to 100? All right, so you can't really see your buttons very well on the paper, but what is my probability of getting a white button? Okay, Nate again.
1.5. 1 and 2.
How many white buttons do we have?
Oh. We have 4.
We write our probabilities, P parentheses. This is said probability of white. Whatever's in your parentheses, there is an of between probability and that value. So probability of a white button, and we could say button or we don't have to since we know we're working with buttons. How many are there that are white? Well, as you said, there's 4. How many total buttons are there? 10. So this then becomes 0.4 or 40%. So how would we phrase this? How would we give a word to it? Is it likely that you're going to draw a white button?
It's unlikely.
Yeah, so it's unlikely, but it's not very unlikely. So I would maybe say somewhat unlikely. Or you could say just under half, or things like that. Like you could assign verbal for whatever you're trying to do. If my event that I'm looking for when rolling a number cube, which is another way to talk about a die, is rolling a 3, what is my probability of rolling a 3? Grace?
1 over 6.
Yeah, 1 over 6. Which as a decimal would be 0.16 with the 6 repeating. Now, Olivia, what's the probability of getting an even number when I roll a number cube?
1/2.
Yeah, that would be, and I'm going to show the work. That's really 3 outcomes over 6, which reduces to 1/2, which becomes the 0.5. Remember, when we're asking about probability, we're talking about the fraction or the decimal. When we talk about the percent, that's not actually the probability, because probability has to be between 0 and 1. So the percent is how likely it will occur, but when we ask for probability specifically, we're talking about fraction or decimal. So Mr. D is standing at, different question. I'm getting ahead of myself. Band director is going to choose one trumpet player at random to lead the band in the holiday parade. Now you need to be able to see who is in the band. Did you log me out? Don't log me out. Here we go. Yay. So we got to see who's in our band. Sorry, we can't actually do us. This is when Smartboard becomes problematic.
There's 4 in our game. 6. 6 if you don't know.
Wait, no.
Hey, stop looking at me.
There's 6.
I'm not a bander.
Total.
I just am band.
Dude, wear it proudly.
4 and 6. 7th grade and then 2 and 8th grade.
So here's our band.
So there's 6.
Here's our band. We've got our made-up band because I didn't want to pick on any actual band people.
Hey, look, there's 2.
So what's the probability
Hey, I'm a trumpet player. So that's
that we will choose a boy with this lineup of trumpet players? What's the probability that we will choose a boy? Well, how many boys are up here? I would assume that Seth is probably a boy, James is probably a boy,
Yeah.
and Raul is also a boy. So 3, how many total trumpet players are up there? 8, so it'd be 3 out of 8. Now when we look at probability of wearing a striped shirt, probability of stripes. Yeah, I know, their fingers are not up on the valves. Sheeb?
2 over 8.
Okay, let's check for all striped shirts. I see striped shirt here. I see striped shirt here. I think that's it. So, like Shahib said, we have 2 over 8, which actually can simplify to 1/4.
Which is
Questions, comments, concerns on what we're doing? Good. So let me check that I'm still with your notes. So we have this spinner. It's a 10-section spinner. Why is 10 not on here?
Because there's 0 instead.
Because 0 is on there. What is the sample space? So I want you to write sample space. What is the sample space for this spinner? Zach?
So, no, this is a question.
Okay.
So, like, if they were asking what is the probability of, like, rolling or spinning an odd number, what would you count 0 as?
So 0, that's often a point of contention. People will say that 0 is either even or it has no value. And we can get into that argument another day, but we only have like 30 seconds left. So I'm not worried about that right now. That's not what we're asking. So what we want to identify is when I talk about the sample space.
Isn't it all, it's all of them.
Yeah, so I would say it is.
1, 2, 3,
Yep.
4, 5,
We
6,
list it out. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I list out the entire sample space, every single option. Then how many outcomes? Well, my number of outcomes is 10. And that's all we have for today. I will get your homework posted. Go ahead and give it a shot. If you're going to Stone Lab, have fun at Stone Lab. If you are going to Macbeth, it's going to be sweet. Are you excited about that? I think as long as there's space on the bus.
Not salty.
And have a wonderful day, guys.
You're not like